Okay, hello everyone. In this session, we are going to discuss problems based on the projection of lines. Already, we have covered some problems based on this projection of line in part 1. So, this will be the part 2 for this video. In that, we are going to solve all these three problems. So, the first problem is draw the projection of line AB if its true length is 65 mm, inclination with FRP is 45 degree, and if the end B is 45 mm above the HRP. So in this problem, they have given true length is equals to 65 mm, and this inclination with FRP is nothing but the angle phi that we are going to represent in a top view projection with respect to considered line. And the point B is 45 mm above the HRP. So this 45 mm distance we are going to project in a front view with respect to drawn XY reference line. So let's start with this. So initially we have to draw one axis which will represent the projection in front view as well as in a top view projection. So already I have prepared layers for constructing these projection lines as well as the object lines. So this is nothing but the projection layer, and this we are going to use to draw projection for the lines. Okay. So initially I will just go with this projection. Again we have to draw one horizontal line which will represent XY axis over here. So to have exact horizontal line, just turn on this ortho mode command, select a point over this workspace and draw one axis line like this. Okay. Now in this problem they have not given the initial reference point at a particular distance. So we are going to take 15 mm distance with respect to this drawn XY line. So just to have this, go with this copy command in a modify toolbar, select this object line, press enter button. Again you have to specify the base corner point with respect to we are going to copy this line, and you have to mention distance 15 over here. Again you have to move your cursor in a downward direction. Again you have to enter 15 mm distance and press enter button. So on either side we will have these two lines, and just press escape button to come out of this selected copy command. Okay, now this will be the XY axis, and this is nothing but the locus line for the point A in a front view, and this will be the locus line for the point A in a top view projection. Now we are going to start with this end point so that we can have the line over here for the distance 65 mm, which is nothing but the true length for this line AB. Now to have that, just go with this object layer. Okay, select this. Again you have to select this line command. Suppose this will be the starting point for that line in a front view, and you have to enter distance is equals to 65 mm. So just press enter button. So over the screen you will see we have drawn a line AB of 65 mm length. Again the same line we can draw in a top view projection over here. So just press enter button to activate previous command. Again select this as a starting point, move your cursor to the right side, again enter 65 mm distance. So by this way we have two lines in a front view as well as in a top view projection. Okay, so these are nothing but the two length lines. Now in this case they have given inclination FRP 45 degree, so that we will have in a top view projection. Okay, so that we are going to represent true length of this given line. So let's draw this line. Again just go with the line command. To have that inclined line, turn off this ortho mode command, select this starting point, and here you have to draw a line for this length is equals to 65 mm, and we are going to consider inclination 45 degree. So just enter 65 length, press tab button, mention the inclination 45 degree, so that we can have this two line over there. Okay, now once we're done with this, the second point of consideration is that we have this end B 45 mm above the HRG. So that we are going to draw over here in a front view projection. So to have that line, we can refer this middle XY axis. Okay, and that we are going to offset at a distance of 45. So just go with this offset command in a modify toolbar. Select this. You have to mention offset distance 45. Press enter button, and you have to select this XY line and move your cursor in upward direction and just click once over there. So we have this line above this XY axis at a distance of 45. Now once we're done with this, we can start for the actual projection. Now we have this 45 degree inclination over here, which will represent true length in a top view projection. Now how we are going to find the true length over here? We can just rotate this true length line in anti-clockwise direction so that we can have intersecting point over this locus line. Now to have that, just go with this arc option. In that you have to select start, center and end. This will be the starting point. Okay, this will be the end point, and you have to move your cursor in upward direction so that we can have that arc over there. Okay, so just click once over there like this. Now this line we are going to represent in a projection layer. Okay, so just select that line, go with this projection option and press enter button, so that we have converted that object line into projection line. Okay, now we can trim out this extension line by selecting this trim command. Just press enter button and click over here. So by this way we have trimmed out this extra portion for that drawn arc. Now if we just join this point and this point, we will have true length over here. Okay, again you have to go with this object layer, select line command, again just join these 2 points. So by this way we can have true length in a front view projection. So just click over it like this. So we have true length in a front view as well as in a top view projection. Okay, now in this case we have locus line for this end point B. The same locus line we have to complete over here as well in a top view. So again to have that, we will just go with this offset command. Okay, again we have to specify the distance. So this will be the starting point, this will be the end point for that offset. Again select this line and just press enter button. So by this way we can have this locus line over here as well. Okay, now in this case we have drawn these projection lines for the larger distance so that we can trim out. So again just go with the line command, just turn on this ortho mode command, select this line command, draw one vertical line. By means of that we can trim out all the extension lines that we have to the right hand side. Again just go with the trim command, press enter button and just select all that lines like this. Okay, so we have trimmed out all these extension lines. Again just select this line that we have taken for the reference and press delete button over the keyboard. So by this way we have confined our workspace to solve this problem. Okay, now once we have these projections, the remaining thing is that we have to find apparent length in a top view as well as apparent length in a front view projection. Now how we are going to find it? So in this case, first of all we have to transfer this true length in upward direction so that we can have intersecting points over here, and from that point we are going to draw an arc which will get intersecting point over this locus line B. Now once we find that point, just connect this point to the starting point A. So just go with this projection layer, again go with the line command, select this point in a top view projection for the true length, and that point we are going to project in upward direction. So from that point we are going to draw a vertical line like this. So just click over here and press enter button. Now this will be the starting point. Okay, again we can draw an arc by means of this second option. Select this as a starting point, just zoom it to have the starting point. This will be the center point over here. Select this as a center point and we can complete that arc somewhat over here like this. Okay, we can extend that arc by selecting this arc like this and just move this extension point like this, or we can just delete that drawn arc and we can draw it once again. Okay, again just go with the arc command, select this starting point, the center point and click over here. Okay, so again go to the trim option, press enter button, just trim out the extra line. Again you have to change this projection layer, go with this object line, select this line command, turn off this ortho mode command so that we can have this inclined line with respect to this intersecting point like this. So by this way we have found this apparent length in a front view projection. Okay, now already we have gone through these basic concepts. We know that all the apparent length points are in line with each other. So directly we can transfer this intersecting point in a top view projection so that we can have intersecting point over here. So again just change this projection option, go with the line, select this intersecting point and draw one vertical line like this. Over there we will get intersecting point. Okay, again to have that object line, change this option, Again select this line command, draw a line which will connect these 2 points like this. Press enter button. So by this way we have completed projection for the given problem statement. Now the remaining thing is that we have to give nomenclature for all this. Okay. So before that, first of all we will just complete the dimensions. Just go with the linear dimension. Select these 2 points so that we can have true length over here. Okay. Again just turn that objection lines to the projection. Press enter button. Make sure that we are going to provide all the dimension in projection layer. Okay, again just go with the align dimension, select this apparent length point, this one as well as this one, and mention that dimension in a front view. Again press enter button to activate this dimension line. Again select these 2 points. So by this way we have found apparent length in a front view as well as in a top view projection. Already we know the true length inclination over here. Now to have that accurate inclination measurement, go with this angular option, select this true length with respect to this reference line. Again press enter button, select this apparent length. Again we can have inclination over there. Again just press enter button to activate that previous command. Select this true length. Again press enter button, select this apparent length. So we can have all the inclinations over the workspace. Now the remaining thing is that we have to locate nomenclature for all the intersecting points. So before that we are going to highlight the end points by using donut option. So just type donut over the keyboard, press enter button. You have to specify inside diameter as a 0, outside diameter as a 2, and just go on selecting these intersecting points where we want to show the donut points like this. Again this will be the intersecting point. Again you have to select this one, and this one like this. Just press escape button to come out of this. Now the remaining thing is that we have to give nomenclature for all these drawn construction. So just go with this text option. In that you have to go with the single line text. Click anywhere over the screen and you have to mention text height is equals to 2.5. Press enter button. Again you have to mention rotation angle 0 degree. Press enter button and just move your cursor where you want to give nomenclature for that drawn line. So this will be the point AF. Okay, this will be the point BF. This will be the point B dash F. This will be the point B double dash F. So just click over here, B double dash F. Likewise, just zoom out the portion for the top view. This will be the point AH. This will be the point BH over here. This will be the point B dash H, and in that case we have to find out this point which will represent point B double dash H. So by this way we have completed our first problem. Okay, so this is all about the solution for the first problem statement. So in that case we need to find out its apparent length, apparent inclination in front view as well as apparent length in top view and apparent inclination in front view projection. Now we will solve second problem. We have a problem statement like this. A line AB has its front view length 50 mm with a true length of 70 mm. The apparent front view inclination is 45 degree. Draw the projection of line AB and find its true inclination with HP and VP. So in this problem they have given apparent length as well as true length. So this front view length is nothing but the apparent length in front view, and this true length we are going to project for this true inclination, but we don't have the true inclination in a given problem statement. That we need to find out, and we have the apparent front view inclination 45 degree, which is nothing but the angle alpha. So that we are going to mention this front view length 50 mm. So let's start with this problem statement. Again we have to draw XY axis. We have to just confirm we are constructing all these drawings in a projection layer. Again just select this line command, just turn on this ortho mode command. Now if I move my cursor over this XY axis over here, you are able to see that we have one projection line like this. So the same reference line we can continue to have XY axis over there. So just move your cursor with respect to that end point it will guide us at what point we are going to start for the xy axis. So just select one point over there and draw xy axis like this at any particular distance. Again just go with the copy command so that we can have a line on either side. Select that object line, press enter button, mention the distance as 15 mm, move your cursor in upward direction. Again move your cursor in a downward direction and mention 15 mm distance like this. So by this way we can have the starting line on either side of this xy axis. Just press escape button to come out of this selected line. Okay, now this point we can select as a starting point. So in this case we have true length is equals to 70 mm. So we can draw a true length line with respect to this drawn locus line for the point A in a front view and top view projection. Again just change this object line, go with the line command, select the starting point, mention distance 70 mm, press enter button. Again press enter button to come out of the selected line. Again press escape button or the space button to activate our previous command and just mention the same distance over here in a top view as well. So by this way we can have true length in a front view as well as in a top view projection. Now in this problem statement they have given front view inclination is equals to 45 degree, which is nothing but the alpha angle, front view inclination. So just change this projection layer. Again turn off this ortho mode command, go with the line, okay, and with respect to this point we are going to draw a 45-degree inclined line over which we are going to mention front view length is equals to 50. Okay, so just enter length is equals to 50 mm that we have in a problem statement. Press tab button to activate the second window, type 45-degree angle over there and press enter button. So this will be the apparent length we have in a front view. Okay, so that we can turn into object line by selecting this like this. Okay, again we need to draw a locus line for this end point. To have that just go with this copy command, or you can go with this offset command as well. So just go with the offset command. You have to mention this distance with respect to this point. So this will be our starting point and this will be our end point for that offset line. Select this line, move your cursor in upward direction and click once over there. Okay, so which will represent locus line for that point B in a front view. Okay, again if you just observe the given problem statement, what we have: front view length 50, top view true length 70 and inclination 45 degree. So already we have this end point over here. So directly we can rotate this true length so that we can have intersecting point over here, and that we can connect to the starting point A, so that it will represent true length in a front view. So just go with the projection line, select this second type of arc, starting point, center point, and just click over here. Again if we just change our object line and we can connect this starting point and this intersecting point, which will give us the true length in a front view projection over here. Okay, now how to find the apparent length in a top view projection? Because in this case only we have distances for this locus line, but they have not given the distances for this second locus line in a top view projection. So if we just recall our first problem, if we just observe carefully, we have this point BH in line with this point BF. Okay, and the same point we will get once we transfer this true length point in a downward direction, and if we just complete that arc over here. Okay, now let me complete this to understand this concept over here. Again I will change this layer to the projection. Just turn on this ortho mode command, go with the line command, select this point that will represent true length in a front view and just transfer it in a top view projection over here. Okay, so that we can have intersecting point over this locus line. Now this length we are going to use to have this end point over here. Now let me go with this arc once again, select this as a starting point, this as a center point. Now you can see that line is going to meet further. Okay, so the same phenomena we are going to use over here. So to have this intersecting point in a top view projection, first of all we need to transfer this apparent length point in a vertically downward manner, and this true length we are going to project vertically downward so that we can have intersecting point over there, and the same point we are going to carry over here. Okay, so let's start with this. Again, go with the line command, select this point, draw a vertical line at appropriate length. Again, just transfer this true length point in a downward direction, select this end point so that we can have intersecting point over here in a top view. Now this point we are going to rotate over here. Now to have this, just go with the circle command, select this as a center point and this as a radius value so that we can have intersecting point over there. Okay, now we have to trim out this extra portion. So just go with the trim option, press enter button and just go on selecting the extra lines that we want to trim out over here. So just click over there like this. Again, you have to click at this point. So these are the extra lines that we have drawn for our understanding. Okay, so by this way we will have intersecting point over here which will represent apparent length in a top view. So again, just go on selecting this object layer, go with the line option, select this starting point and this intersecting point. Turn off this ortho mode command so that we can have inclined line. Now select this intersecting point. So this is nothing but the apparent length in a top view projection. So over there we can transfer this locus line and we can complete this true length over here as well. So we can go with the offset, select this distance, this one and this one, select this line and move your cursor in downward direction. So by this way we can have locus line for that as well. Now to have this true length over here, again we have to go with the circle command so that we can have intersecting line over there. Okay, so just go with the circle command. Again you have to specify this as a center point and this as a radius value. So by this way we can have that arc over there. So just turn this object line into projection line like this. Again go with the trim command, press enter button and just go on deleting these lines. Now we are interested in this line only. So just delete all the previous lines like this. The end line we have to select once again and press delete button over the key. So this will be the intersecting point which will represent true length over here. Okay, so again go with the object layer, go with the line option, select this starting point and this intersecting point. So by this way we can have true length in a top view projection as well. So this is the solution for the second problem. So the only remaining thing is that we have to complete all the nomenclature that we have given in a previous problem. Okay, and we will have the same nomenclature over here as well. Now in this case I will just measure the inclination for the true length in a front view. So just turn this into the projection line, press enter button. Again measure the apparent inclination because this is what they have asked in a question. You have to measure the apparent inclination and true length in a front and top. Okay, again just go with the align dimensions, select these end points and mention those dimensions over there like this. Okay, now just go with the trim option, press enter button, delete this extra portion. Now already we have gone through how to complete this nomenclature. The same nomenclature you have to reflect over here. Okay, so this is all about the solution for the second problem. So this is all about the solution for the second problem. So if you just look out for this third problem, we have problem statement like this: complete the projection of line AB if its true length 60 mm, true angle with HRP 30 degree, point B is 50 mm in front of FRP. Find the true angle of line AB with FRP. So in this case they have given true length is equals to 60 mm. True angle with HRP means they have given angle theta. Over there we can represent this true length 60 mm so that we will get end point in a front view as well. If we just look out over the third point, the point B is 50 mm in front of FRP, which means that we have to take 50 mm distance in a top view projection with respect to XY axis. So already we have covered this first problem. In that they have given this 50 mm distance over here above the HRP. So instead of taking that distance in a front view, you have to take that distance in a top view projection over here. So this distance we have to plot over here with respect to that xy axis. So already we have completed the similar kind of problem for this problem statement. So just try out yourself to solve this third problem. Thank you.